Selection sort. Selection sort is very easy to understand. It sorts an array in passes. So here we select an array having 6 elements 23, 78, 45, 8, 32, 56. This array consists of all the elements which are not in a sorted order. So in the selection sort algorithm, we'll sort each element in passes. So here you have 6 elements. We are going through 5 passes. So first element we'll select and we'll try to identify the minimum element in the next elements. And at the end of the pass, we'll identify the minimum element and we'll swap the element in the correct position. So here the same we explained in the theory. It sorts an array in passes. In each pass, select the next smallest element. So here we have 6 elements. In the 6 elements, first you are selected how to identify the first minimum element. Out of this, normally you can identify it is the minimum element. So here it should be in the first position. You have to swap. So in the next pass, for the second position, you select and identify the next minimum element. Next minimum element is 23. So you have to swap with the second position. That's why you are calling this as a selection sort. Each pass, you are selecting a position and you are identifying the minimum element. So for the first position, you identify the first minimum and you place it in correct position by swapping. In the second pass, you identify the second minimum element, you swap it. So here, the simple logic is here. In each pass, select the next minimum elements and at end of the pass, places it where it belongs. So how many passes we have? Suppose we have 6 elements means we will be having 5 passes. So first element, second element, 5 elements sorted means 6th element is already in its sorted position. So in each pass you have to compare with the identify the next smallest element. So you can see the logic here. We have an array with 0 to n minus 1 elements. So you have to sort the 0 to n minus 2 elements. So first for loop is 0 to n minus 2 elements. So position you want to fill is I equal to 0. Set this as I minimum. Now compare this value at I minimum with the next element values. Next means here j equal to I plus 1 to n minus 1. J equal to I plus 1 to n minus 1. So if any item at the next index is less than the item at minimum, we have to update the I minimum. So here, first for loop is for selecting the position. Second for loop is comparing the minimum value with the next elements. If any value at the next elements, if any value at the next index is less than the value at I minimum, we have to update the I minimum with particular that location. If any value at j index is less than the value at I minimum, update I minimum with particular j. So end of the for loop. So once j equal to I plus 1 to end of the list, we have to update I minimum. Now we have to compare, we have to exchange. You identified the minimum element that you have to swap with the ith position. You selected the position I in the first for loop. Now at end of the for loop, you got the minimum index value. So you have to swap. Just to see here, same. So for I equal to 0, I less than n minus 2, I plus 1. So here we have an array with n elements. So n elements means index is from 0 to n minus 1. 0 to n minus 1. So you have to sort the elements 0 to n minus 2. Once we have sorted elements 0 to n minus 2, last element n minus 1 is already sorted. So here I minimum, you have to set it as I. So set I minimum as I. So initial I equal to 0, then I minimum also initialized with 0. So now we have to compare this with the next elements. Next means from I plus 1. So next value is indexed by j equal to I plus 1 to end of the list. So you have to identify any value at jth index. Next, any value at j is less than the value at I minimum, update I minimum. So this for loop is compared up to the end of the array, up to n minus 1. So finally I minimum is updated. Now we have to check if both are same. Position you selected is 0. I minimum is founded at 0 means no need to swap. But position you selected is I equal to 0. I minimum you found at a particular position you see here. position we selected here 0, but I minimum we found at position 3. Both are not same, so we have to swap here. So you see this condition here, end of the array. End of the array means j equal to 1 to 5 minus 1. So if you compare j equal to 1 to 5 minus 1, minimum value identified at index 3. So now I minimum is updated at 3, but I you selected position 3, 0. 0 is not equal to 3, so we have to swap 23 and 8. So this is the third step you can see. At the end of the pass, places the minimum value where it belongs to. So here, minimum value 8 is at index 3, but it should be at the index 0. Same process you should repeat for the I equal to 1. So I equal to 1, set I minimum equal to 1, compare with the j, all the next elements. Next elements is j equal to 2 to 5. So here, j equal to 2 to 5 means when j equal to 2, j equal to 3, j equal to 4, j equal to 5. While comparing, if any minimum value identified compared to the I minimum value, we have to update. So here, you can see here I minimum is selected as 1 for the second element we are doing. So j equal to 2 to 5, we have to compare any a of j is less than a of I minimum. So initially a of I minimum is here 78. Here 45 is less than 78, update I minimum as 2. Now I minimum is 2. Again 23 is less than 45. Now I minimum is 2. So but now 23 is less than, now update I minimum as 3 value. So up to end of the array, I minimum is here only, because if you are not identified any minimum value less than any less value compared to the 23. So here I minimum is at 3. But initially if I minimum we identified at position 3, it should be at the position I equal to 1. So we have to swap. So you selected the position I equal to 1, but minimum value identified, second minimum value identified at I minimum equal to 3. So 1 is not equal to 3, so swap 23 and 78. Swap 23 and 78. After swapping, you can see 23 occupied its position. Now I equal to 0, I equal to 1 is sorted. Now I equal to 2 to 5 not sorted. Now third time. First for loop I equal to 0, second for loop, second iteration I equal to 1, third iteration I equal to 2. In I equal to 2, now set I minimum is 2 and identify the I minimum in the next element. So the real I minimum is, I minimum we have to update. So 78 is not less than 45. I minimum is still F2 only. Now 32 is less than 45. Now update I minimum equal to 4. Now I minimum update equal to 4. Now I minimum is at location 4. Again check j equal to 5. Is 56 is less than 32? No. Now I minimum is at 4 only. So I want to fill is second location, but I minimum we found at the fourth location. So swap 45 and 32. Swap 45 and 32. So after swapping, you can identify 32 occupies its position I equal to 2. And 45 is here. So each pass one exchange is going on. So in each pass you are identifying the element and you are placing in its correct position. For I equal to 3, I minimum you identified at position 4. Both are not same, we swap 45 and 78. Now for last pass I equal to 4, you identified I minimum at 56. So swap 56 and 78. So here first element, second element, third element, fourth, fifth. Sorted means automatically first minimum, second minimum, third minimum, fourth minimum, fifth minimum in correct place means 60 is in its correct position. So for loop is I equal to 0 to n minus 2. For loop, first for loop is I equal to 0 to n minus 2. So I minimum identified for first position, second position, third position up to n minus 2 position. For each element you have to compare with the next elements. End of the pass you identify the minimum element and swap. So complexity of these selections what are the ways. In each, for each element you are comparing with all n, first element you are comparing with n minus element. So second element you are comparing with n minus 2 elements. Third element you are comparing with n minus 3 elements. So almost its comparisons are n square comparisons. And the exchanges, see here, comparison is in nested in two for loops. That's why it is n square. But swapping is in the first for loop only. So for n elements you are swapping. So first position one swapping. Second position, one swapping. Almost n minus one swappings happened. So it is order of n. So you can see the complexity also here. Comparisons we have order of n square, but exchanges it is order of n. Thank you.